All right, guys. So section 22B is all on proportional relationships, but we're bringing it a step farther. So instead of the proportional relationships, now we're going to get into something called slope-intercept form, which is y equals mx plus b. Okay, a proportional relationship, you might remember from last week, y is equal to something x. Now we're just changing some of the terms in here. So we know this b, like last week, tells me where I start on my y-intercept. This m is my unit rate, or my rate of change. Okay, so it says here that we've studied this in the previous lesson. Use your work from the previous lesson to answer the questions. Well, let's go through here. It says stage 1, they want to know how many blocks there are. Well, there's 1 block at stage 1. At stage 2, there are 4 blocks. At stage 3, there's 1, 2, 3, 4, 5, 6, 7 blocks. Stage 4, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. So I know at stage 5, since I'm adding 3 each time, my y's are going up by 3. Stage 5 has to have 13 blocks because 10 plus 3 is 13. Well, now we're going to look at the pattern between my x values. Every time my x value is going up by 1 point, or 1. So last week we talked about, okay, well, I can find the rate of change by doing my change in y over my change in x. So I know every time I add a stage, my y value is going up by 3. But my x value is going up by 1. So my rate of change has to be 3. All right, so show where you see the rate of change in your table. Well, we just did. It's 3 over 1. Okay, create a graph of these data points. Where do you see the rate of change in your graph? So x is going to be my stage number, and y will be my number of blocks. So after stage 1, there's 1 block. Stage 2, 4. Stage 3, 4, 5, 6, 7. Stage 4, 8, 9, 10. Okay, now when you look at this, I know if this pattern continues, it's not going to, oh man, sorry, should be that point right there. It is not going to go through the origin, because if I go up 3 over 1, up 3 over 1, and up 3 over 1, there we go. For my points, let me just make sure this is right, sorry. So 1 was 1, 2 was 4, 1, ooh, what just happened? 1, 2, 3, 4. 3 should have been 4, 5, 6, 7. Good. 4 was 8, 9, 10. Perfect. So every time I'm going up 3, the right one. I can see my rate of change there. So if I go down here to this point, if I go down 3 into the left one to continue the pattern, go through the origin, right? If I keep mine, they're all my points. It does not go to the origin. It's not proportional. So now we need to figure out, okay, well, here's the rate of change. How do I figure out which 0 where my point is on my y-axis? So to continue this pattern, instead of adding 1, I'm actually going back a stage, right? So I'm actually going back 1 stage, that's the subtract one, to get 0. Well, over here, since I added time, I'm going to go do the opposite. What's the opposite of adding? Well, subtracting 3. And I know if I'm at 0 and this was 1, 1 minus 3 is -2. So we're going to be working on how this works in the days to come. But what you need to understand is y-axis moves down. This line is actually hitting my y-axis at -2. So when I write an equation for this, I get y equals my rate of change, which is x, but it's not proportional. Where does it start on my y-axis? Starts at -2. Okay, so again, this is my rate of change, and this one right here is my y. Now they want me to go in and say, okay, is this pattern a linear pattern? Meaning, does it go up in a line? Yes, it goes up at a constant rate and starts at -2 on my y axis. Describe what you see in each of the representations. A linear pattern makes geometric model or in the block, right? So the block above, they add how many blocks time? 3 blocks each time. So that is my rate of. Okay, for the table, I go up 3, my y's, and my x go up 1. So that would be 3 over 1. That would be my rate. The graph, right, we go up 3 to the right 1 every time, and it's going up at a time. We know that it has to be proportional. And my equation, y equals plus negative 2, or y equals 3x minus 2. That 3 is telling me the rate of change, and that 2 is telling me where I start on my y-axis. All right, let's go ahead and try this. It could be more. Do this with you. So stage 1, there are 4. Stage 2, there are 1, 2, 3, 4, 5, 6, 7 blocks. Stage 3, there are 2 blocks. So that means by stage 4, pattern continues since I'm adding here, here, there's 13, and then 15. How many new blocks are added to the pattern from one to the next? 3. You did that. Show where you see the rate of change. Starting each time. And on my axis, I'm adding 1. So my rate of change is y 3x, or 3 over 1. I'm going to have you guys go ahead and do D. And instead of P, I'm going to keep that Y, and then I'm going to leave that. I'm also going to have you do F. Okay. Number 2, let's do this one. Stage 1, 1 block. Stage 2, there's 1 block. Stage 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. That means stage 4, I'm adding 4 each time. I have 13, and then 17. How many new blocks are added each time? Well, 4. Complete the table. We did. Show where you see the change. So I'm adding 4, and I'm going to put 1 on my x. So my change in y, change in x, 4 over 1. All right, I'm going to have you guys graph it for T. I'm going to have the equation y equals the rate of change x plus, let's take a look up here. If I'm adding 4 each time, if I want to go back a stage to figure out at stage 0 where I start, well, if I go back a stage 4, I'm adding 4, the adding 4 would be subtracting 4. So 1 minus 4 is negative 3. So that means I'm going to start at 0, negative 3. So when I go into graph this, I know my first point is 1, 1, 2, 5, 3, 9. I know when I graph it, it's not proportional, and it crosses my y-axis somewhere down here. So by solving, by going back time, I know I can find my y. All right, I'm going to have you guys do number 3. All right, so that is our lesson on 2B.